In this lesson, we're going to discuss what it means to simplify radicals. We know that simplifying a fraction, such as 6/8, means to reduce so there are no common factors left in the numerator and denominator of the fraction, such as 6/8 would reduce, obviously, to 3/4. We also know that simplifying expressions such as 3x plus 4y plus 2x means all like terms are added together. So in this example, it's not simplified because we can still add the 3x and 2x together. Radicals also have a form that is considered simplified. A simplified radical is one where there are no more factors that are perfect roots under the radical sign. Square root of 4 is a simple example. 4 is a perfect square, so we can factor it out to 2. So 2 is our simplified answer. The square root of 9x squared. This is not simplified yet because 9 is a perfect square factor, as is x squared. So the simplified version would be 3x. Let's look at some that have some perfect roots, but not all. So in other words, some of these have perfect roots I can take out and others don't. So the first one, we're going to do the cube root of 8x cubed y to the 4th. So we're going to go through and simplify that. Now I can break these up into pieces. So we're going to take the cube root of 8. I happen to know that's going to be a perfect cube, so that'll work. And then I'm going to use that rational exponent to do my variables. So I'm going to take the 3 power over the 3 root, take the y to the 4th power over 3 root. So the cube root of 8 is 2, so that's completed. X to the 3 over 3, well, that's x to the 1, so that's x. But the y, 3 goes into 4 one time, but has that remainder of 1. So that remainder goes underneath the radical sign. So this is considered simplified because now there is no perfect cube roots underneath the radical sign. Now I'm taking the exact same problem, but now I'm going to work on square roots. So we do know that we cannot take the square root of 8 perfectly. There is no square root of 8. So I'm going to have to break that down into factors that would be a perfect square. So 8 can be rewritten using square root of 4 times square root of 2. Remember our properties, you can multiply what's underneath the radical signs together, or you can break them up. You can go either direction. So square root 4 times square root 2 is equal to square root 8. Square root 4 is perfect. That gets me 2. So the square root 8 has become 2 with a leftover 2 underneath the square root symbol. Now let's take the x and do the same thing, only this time now our root is squared. So x to the 3/2. 2 goes into 3 one time, so our 1x comes out with a remainder of 1. So the remainder remains under the radical sign. Now the y has a power of 4, but now we're over the root of 2. 2 goes into 4 twice, so y squared comes outside the symbol. There's no remainder. So again, this is simplified because when you look under the square root sign, neither 2 nor x contain perfect squares. So these are considered simplified. Here are some more examples. Let's take the cube root of 24. Obviously, there is no perfect cube that's a 24, but we can break it up into perfect cubes as factors. Well, we know that the cube root of 8 is 2, and 8 is a factor of 24. So I'm going to break up 24 as the cube root of 8 times the cube root of 3, because 3 times 8 is 24. So again, we know the cube root of 8 is 2, so that simplifies to 2. But there is no cube root of 3, so that stays underneath. So that is our simplified radical. Now I've done a square root here of 48. Now I picked this one to show you what happens if you don't recognize the largest perfect square underneath first. So let's say, for example, most people looked at this and said, oh, you see 48, that would be 4 times 12. So they would do square root of 4 times the square root of 12. And they'd say, okay, well, square root of 4 is 2. So they end up with 2 square root 12. But now when you look at the number 12, you realize, oh, 4 is a factor of 12. So I can continue to simplify. So now I'm going to break up the 12 into the square root of, whoops, this, let me erase that. Square root of 4 times the square root of 3. So the square root of 4 is 2 again, and 2 times 2 is 4. So 4 square root 3 is simplified. This just means that originally I could have broken 48 up as the square root of 16 times the square root of 3. And then I would have gotten the same answer. But it's okay that I didn't see that at first, as long as I checked my radical at the end and made sure I didn't have any other perfect squares underneath it. So here's one that's got multiple terms. Again, it's square root. We'll start with 50. I need a perfect square number that is a factor of 50. Well, again, I know square root 25 times the square root 2. 2 times 25 is 50. So the 25 becomes 5. So I have 5 and I have square root 2. Let's go to the x part. X to the 5 over the square root, 5 halves. Y, power of 2 over root 2. And z has a power of 1 over the root 2. So when compiling my answer, I'll put down my 5 from the original, 5 square root 2. And then I'll start with the x and say, 2 goes into 5 twice with a remainder of 1. So there's one remainder of x underneath. Y, 2 over 2 reduces to 1, so 1y comes out. The z, on the other hand, is to the 1/2 power. That's the square root of z. It basically can't come out. There's nothing I can do with it. So it leaves me with a final answer of 5x squared y times the square root of xz. Now I'm going to have you try these problems. Again, you will pause the video, work these problems out to the best of your ability. Then when you are completed, you can restart the video and work along with me to check your work. Let's see how you did. The first one is a cube root. I have the cube root of 40, a to the 5th. So let's start with 40. I'm looking at my perfect cubes. Well, 2 cubed is 8, 3 cubes is 27. Well, it looks like 27 is too big. So we're going to break it up into the cube root of 8 times the cube root of 5. 8 times 5 is 40. My a, I can go ahead and write that as my power of 5 over cubed. So going through here, I see, okay, cube root of 8 is 2. So 2 is on the outside. I know that I'm left with cube root 5 underneath. I take the a and say, well, 3 goes into 5 twice. Or excuse me, 3 goes into 5 once. So only one a comes out with a remainder of 2. So a squared stays underneath. So 2a times the cube root of 5a squared. Now let's take a look at the square root of 32. We know 4 can go into it. That's a perfect square. The next perfect square, 9, that doesn't work. But I do know that 16 does. So I'm going to go straight to the fact that 32 is equal to 16 times 2. So the square root of 16 is 4. So my simplified radical is 4 square root 2. And the last square root one just has multiple terms. So square root 100, well, that one's a perfect square. That'll work out nicely. I'm going to take a to the power of 8 over to the root. That one looks like it'll come out nicely. B, I'm going to transpose to power of 5 over the root of 2. Looks like there'll be a remainder. And C to the power of 3 over the root of 2. So starting with the 100, that's a perfect square. So I know 10 will be outside the radical sign. A, 2 goes into 8 4 times evenly, so A to the 4th is outside the radical. It came out. No remainder, nothing stays under. Where the B, 2 goes into 5 twice, so that twice means B squared comes out, but I had a remainder of 1. So I do know underneath the radical sign will be 1B. Looking at C, 2 goes into 3 one time, so 1C comes out. There's a remainder of 1, so 1C is left over. And there is our complete answer. 10 a to the 4th b squared c square root bc.